Hello, this is Mrs. Liu. Let us look at this chemistry question. The table shows some information about the homologous series of organic compounds called aldehydes. So this is methanol. Meth means it's 1 carbon. Eth means it contains 2 carbon. Prop means it contains 3 carbon. And you can see that they all have a similar functional group, which is actually CHO. So because they have the same functional group, means they have the same functional group, they are in the same homologous series. So later, I'm going to draw the functional group CHO over here. And we also know that for consecutive members in the functional group, in the homologous series, consecutive member in the homologous series, there is an increase of a CH2 group. This one, there's an increase of CH2. So where is this increase in CH2? Let me show you. It's over here. Can you see this one to this one? There is an increase in CH2. So for the next one, I'll just copy everything here and I'll add a CH2 over here. Okay, so now I'm going to draw it in for you. Okay, so this one I'll just copy, which is the CH3. Okay, this additional CH2 and the functional group CHO. So this is CH3, there's additional CH2, there is a CHO. This is the functional group. If you're not sure, look at the one on top and look at the one on top here. With reference to the structural formula, explain how you deduce that these molecules are from the same homologous series because they all have the same functional group, CHO. Okay, so because they have the same functional group, okay, we can tell that they all belong in the same homologous series. Okay, they have the same functional group, which is CHO. Hence, they belong to the same homologous series. So for example, your alkene, you have double bond, right? So because they all have double bond, so they are all in the same homologous series. Okay, this is an aldehyde functional group, can you see? So same functional group, so same homologous series. Okay, the next question. State and explain, okay, the trend in the boiling point of the aldehyde shown. Okay, what's the trend of the boiling point? Okay, so don't be worried. This is actually same as the trend in your alkane homologous series and your alkene homologous series. In the alkane homologous series, you know that the boiling point increases down the homologous series, right? Because there is increase in the size of the molecules, right? Okay, so there is more forces or more intermolecular forces of attraction. Okay, so you need more energy to overcome all these forces. So therefore, it leads to the increase in boiling point. And we know that alkane, and aldehydes, they all have the same structure, which is the simple molecular structure. And hence, the boiling point will increase. Okay, let me type in the answer for you. The boiling points of the aldehyde increases down the group. Okay, so you've just stated, you actually need to explain. So we know they are all simple molecular compounds. So going down the group, the size of the molecules increases. There is stronger, say stronger or more intermolecular forces of attraction. The molecules. Hence, more energy is needed to overcome these forces. Hence, the boiling point increases. Okay, thank you for joining me today. That's all for today. Remember, you are a miracle.